Hello and welcome to 2.2 Greatest Common Factor. Now 2.2 is a two-part lesson. Today we will talk about how to find the greatest common factor using a list. The next lesson will be finding the greatest common factor using a tree diagram. So the objective is that students will find and use the greatest common factor of two whole numbers. Now, the greatest common factor, often abbreviated as GCF, is just the greatest factor shared, or in common, by both of those numbers. Okay, so the definition is literally what it sounds like. We are going to find factors of two numbers. We are going to decide which ones they have in common, and then we will decide which is the greatest of those. So your first example here is find the GCF between 24 and 36. Now, it would make sense that we would start by listing all of the factors of 24 and all of the factors of 36 so that we can decide which ones they have in common. So I'm going to make a list for 24 and a list for 36. Now, when you start listing factors of numbers, you always start by listing 1 times that number. So in this case, 1 times 24. And I'm going to write 24 way over here because I'm going to fill in the space between 1 and 24 with other numbers. So write them far apart. So this is saying that 1 times 24 is 24. Okay, and then from 1, I move on to the next number, 2, and I ask myself, is 2 a factor of 24? And it is, so I write 2, and 2 times 12 is 24. 2 times 12 is 24. And then I check 3, is 3 a factor of 24? Well, it is, and 3 times 8 is 24. And then I would check 5, or sorry, I skipped 4. 4, I would check 4. And 4 is a factor of 24, so I write 4 times 6. 4 times 6 would give me 24. And then my next number would be 5, so I check, is 5 a factor of 24? And 5 is not a factor, so I move on to the next one, which is 6. However, notice 6 is already written here. So once you get to a number you already have down, your list is complete. So I have 1, 2, 3, 4, 5, 6, 7, 8 factors for 24. And notice this is called the rainbow method because what I just did created a rainbow. Okay, now I'm going to do the same thing for 36. So again, I will always start with 1 and 36. Okay. Then 2, and 2 is a factor of 36, so I will write 2 and 18. And then I check 3, is 3 a factor? And it is, so 3 times 12. And then I check 4, 4 is a factor, 4 times 9. I check 5, 5 is not a factor of 36. I check 6, 6 is a factor of 36, and in fact, that's 6 times 6, so I'm just going to list 6 once. I could write it twice. I'm just going to list it once. I know 6 is a factor. I would check 7. It's not a factor. 8 is not a factor. And then again, I'm at 9, and I already have 9 written down, so I am done with my list. Okay, and I did not connect these with a rainbow. You can if you want to. I just chose not to. So, because we're trying to find the greatest common factor, I'm going to go ahead and circle all of the ones that they have in common, or in other words, all of the factors that they share. So 1 and 2, they both have a 3, they both have a 4, they both have a 6, and they both have a 12. And I believe those are all of the ones that they have in common. Now, since I'm trying to find the GCF, the greatest one that they have in common, I'm just going to choose the largest of the ones I just circled. Well, the largest of them was 12. So I'm just going to say the GCF between 24 and 36 is 12. All right, next example. We're going to find the GCF between 12 and 15. So again, I want to start by making a factor list for 12 and a factor list for 15. So again, I always start with 1 and the number, so 1 times 12. And then I move on to 2, and 2 is a factor of 12. It is 2 times 6. Then I move on to 3. 3 is a factor of 12, and it's 3 times 4. And then, of course, my next number would be 4, but I just wrote that down. So my list is complete. There are 6 factors for the number 12. I'll do the same for 15. I start with 1 and 15. I check to see, is 2 a factor of 15? And because 15 is odd, 2 is not a factor of 15. But then I ask myself, is 3 a factor of 15? And it is. So it's 3 times 5 is 15. And then I would check 4. Is 4 a factor of 15? No, it is not. My next would be 5. I already have 5 written down, so my list is complete. So I'm going to circle the ones they have in common. 1, 3. And that looks like that's all of the factors that they have in common. So then the greatest of those factors, or the GCF, is 3. Next example is between 40 and 56. So I list the factors for 40, and I list the factors for 56. So again, I'm going to start with 1 and 40. I know 2 is a factor of 40, 2 times 20. 3 is not a factor of 40, but 4 is, and that would be 4 times 10. And then I can use commas to separate these, sorry. Okay, and then I can check 5. Is 5 a factor? And it is. That would be 5 times 8. Okay, and then I would check 6. Is 6 a factor? No. Is 7 a factor? No. The next one would be 8. I already have 8 written down, so this is my complete list right there. I'm going to do the same for 56. I have 1 and 56. 2 and 28. Okay. 3. If I don't know if it's a factor, I could do some long division off to the side to see if it works out. Or I could use the divisibility rules we talked about in 2.1. And the divisibility rule for 3 says if the sum of the digits is divisible by 3, so 5 plus 6 is 11. So if 11 was divisible by 3, then 56 would have been divisible by 3. Well, 11 is not divisible by 3, so 56 is not divisible by 3. But I could check to see, is it divisible by 4? Okay, and this one, well, I might not know this off the top of my head. So you might need to do some scratch work, okay, and see if 4 divides into 56 evenly. So 4 goes into 5 once. 1 times 4 is 4. Do some subtraction. 16. 4 goes into 16 4 times. 4 times 4 is, sorry, I'm running out of space, 16. Do the subtraction, you get a remainder of 0. And because you got a remainder of 0, that means 4 does divide into 56, and in fact, it does 14 times. So 4 and 14. 5 does not divide into 56 because the last digit is not a 0 or a 5. Okay, how about 6? 6 does not divide into 56, but we could try 7. And in fact, that's one of our multiplication facts, is 7 times 8 is 56. And again, I've closed the gap between these middle numbers. That means my list is complete. So I circle the ones they have in common. 1, 2, I see 4, I see 8, and that looks like that's it. So then I list that my GCF is 8. That is the greatest factor that they share. And finally, my last example here, I am now finding the GCF of 3 different numbers. So this works essentially the same with one key idea. 12, 36, and 54. Okay, I'm going to list my factors of 12. Well, that's 1 and 12, 2 and 6, 3 and 4. And my list is complete because I've closed the gap between 3 and 4. There's no other numbers between 3 and 4 that I could test. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. And then, of course, we skip 5 because 5 is not a factor. We check 6. 6 is a factor. Okay, and then I could check 7 and 8. 7 is not a factor, 8 is not a factor, and of course 9 is already there. Then I can try 54, 1, and 54. 2 and 27. We could ask ourselves, is 3 a factor of 54? And again, the divisibility rule for 3 says that you take the sum of the digits, 5 plus 4 is 9, and if the sum is divisible by 3, so if 9 is divisible by 3, then our original number was divisible by 3. Well, 9 is divisible by 3, so 54 is divisible by 3. And again, we might not know what that is off the top of our head, so you might have to do some scratch work. And I'm just going to do the scratch work over here. 54 divided by 3. 3 goes into 5 once. 1 times 3 is 3. I do some subtraction. 5 minus 3 is 2. Bring down the 4. 3 goes into 24 8 times. 8 times 3 is 24. We get a remainder of 0, which is good because that means 3 divides into 54 evenly. So 3 times 18 is 54. I could check 4 to see if that works. 4 will not evenly divide into 54. If you do some long division, you'll find that out. You'll have some type of remainder. I could check 5. Well, the number does not end in a 0 or a 5. Okay, the last digit is 4. So 5 will not work. I could try 6. Well, in fact, I know that 6 times 9 is 54. That is one of my multiplication facts. That is something you should know. And then, of course, I would try 7. 7 does not work. I would try 8. 8 does not work. And then I go back to 9. Well, I already have 9 on my list, so my list is complete. Now, the key catch for finding the GCF between 3 numbers is that you are circling the factors that are common to all 3 of them. It can't be just 2 of the numbers. It has to be in all 3 of them. So 1, 2, and 3 I see in all of them. For instance, the number 4 I see as a factor of 12 and as a factor of 36, but I do not see it as a factor of 54. Therefore, I am not going to circle it. So it must be common to all 3 of these numbers. And again, I see a 12 and a 12, but no 12 for 54. So that means I've found all of the common ones. And of course, the greatest out of those factors is 6. So the GCF between 12, 36, and 54 is 6. Okay, so your homework is the 2.2 worksheet part A. Like I said, this is a 2-part lesson. This was part A, so you're doing worksheet A on Schoology. You can see that this section will be difficult if you're not up on your multiplication facts. So I recommend that you practice outside of class on your multiplication facts if you are struggling with those.